Hello, everyone, and thanks for joining us, and welcome to be part of this webinar about the Meteodyn WPA software. My name is Anthony Dijon, and I'm a business engineer for Meteodyn. I'm working from the headquarters of Meteodyn in France, and I'm with my colleague and expert, Mintang Do, with also the Meteodyn WPA specialist for Meteodyn. Hello, Mintang. Can you hear me?
Hello, Anthony, and hello, everyone. I'm Minh Tong Do. I'm the head of the energy division in Meteodyn. I'm responsible for the products Meteodyn WPA, the wind farm performance analysis software.
Thank you, Mintang. So, for those who do not know Meteodyn, in a few words, Meteodyn is a French company expert in wind engineering and in climatology and meteorology since 2003 now, so almost 20 years. And Meteodyn is a world leader in numerical simulation in the wind industry. So numerical simulation, also called CFD. So our competencies do not only touch the wind energy sector. We also use our know-how for two other sectors. So urban planning and for wind safety as well. So wind safety of harbors, tower cranes, trains, and stadiums, and many more. So Meteodyn is a specialist for providing advanced wind studies and providing turnkey software to its users. So the agenda for this webinar in 4 points. The first one, an introduction on Meteodyn Universe, so our wind power software suite. The second point will be on Meteodyn WPA, of course, so about the user interface and about the main features. Of course, we'll introduce you. The third case will be very interesting for you because it will be an analysis of a specific case, Loudborn, to be precise, which is a French wind power plant. And the last point will be a Q&A session. So, of course, be free to ask us questions thanks to the panel on your right. And we'll answer them at the end of this webinar. So be free to ask us questions. So to start, Meteodyn has developed the Meteodyn Universe software, which is a platform, where we gather 5 software products. So the old one, I mean, the one who a lot of people know because it's the leader in the industry, Meteodyn WT, which is a wind resource assessment software of Meteodyn WT based on CFD technology, and the new 4 other software. So GCS, the Global Climate Data Service software, the Wind Data WDA, of course, the wind data analysis software, WFO, the wind farm optimization software, and the one we will speak right now is WPA, the wind farm performance analysis software. So to be clear and brief, this platform gathers all the modules, but all of these modules can be used independently. But the main benefits for the users is all the software work in synergy, and the users doesn't need to use several software programs and manage different files formats. So no import, export process, nothing like that. So it's super easy to use and faster than ever to develop wind farm project. Sorry. And last point, very important, we have developed a lot of tools for teamworking. So thanks to this software, you can work with your colleagues very easy. So about the Meteodyn WPA software. So what is Meteodyn WPA? So Meteodyn WPA is a software which giving you all the tools you need to make diagnosis of your wind power plants. So WPA means wind performance analysis, wind farm performance analysis. Sorry, and so that's why. So it provides a lot of tools for this matter. For this, yeah, we have developed a lot. I mean, we have improved a lot our user interface. So in order for the users to be easy to use, and because this kind of software need to be nice to look, to be used. So that's why we have made very simple 3 layers. So the first map, the first layer is a world map point of view. So thanks to that, you get a simple overview of all your wind farms. So all your wind farms is saved in a database, either a local database or a remote one. The second layer is a wind farm point of view. So thanks to this layer, you can have a deeper information on a particular wind farm. So you can select one and go in it and have key indicators. And the third layer, maybe the most important, you can go deeper and go to the wind turbine point of view. So inside you will have a lot of information about each wind turbines of your wind farm and get best information you need in it. So of course, we will show you later during this webinar the software. So, well, the main features of Meteodyn WPA. So it is very important to clarify, to use Meteodyn WPA, you only need the wind turbine SCADA data, and only that. You don't need to use log files or error files. You only need SCADA data, and thanks to that, you can have the following features. The first one is you can detect and identify wind turbine measurement failures. The second main feature is an automatic detection of wind turbine operating status, defined and developed by us, Meteodyn. The third point is a real power curve recalculation from the SCADA data. Very interesting. The fourth point is you can perform wind farm analysis by loss identification. And the five, and yeah, you can display a lot of key indicators to monitor your wind farms. So the first one, to detect the measurement failures, maybe Mintong, you can explain us how it works.
Yeah, I'm glad to. In fact, the detection and the identification of the wind turbine measurement failures is implemented on the whole time series data. And our algorithm is able to detect and classify the total of 14 measurement value category, different category. And the detection is not only based on the threshold min-max value, but also we provide also the smart algorithm of detection, such as an hidden of the data logger. For example, if your data logger measure the wind speed constantly at 10 meters per second during 1 hour, it's clearly that there's something wrong here with the measurement system. So our algorithm could be capable to detect this kind of situation.
Yeah, totally. So if I'm summing up what you said, it's an automatic data filtering tool, and WPA will automatically and smartly detect the wind turbine measurement failures. So the second point, very important from WPA, is the automatic detection of wind turbine operating status. Can you say more about it?
Yeah, in fact, this detection algorithm is the heart of our computation algorithm. We provide two different algorithms to detect the operating status with and without the pitch. As you know that the pitch is the angle of your blade of the wind turbine, so the presence of a pitch could help us to increase the accuracy of our detection algorithm. But in some case that user cannot have this variable in the data, so we develop specially an algorithm to detect and classify the operating status of wind turbine with a pitch. And we separate the operating status of the wind turbine into eight category.
Eight categories.
Yeah, the first one is the measurement errors, which has been presented previously. And after detecting the measurement value, those points will be excluded from the further analysis. And then secondly comes the underproduction and the overproduction. Those are the point with, for example, underproduction is the point that the wind turbine perform under the estimated output power, and the overproduction is the point that the wind turbine produce more than expected. However, this is just an illusion because the real cause of this overproduction is the mistake in the measurement of the wind speed. So the wind sensor give a value which is lower than the reality. So when we project to the power curve, we will see that we have much output power, but for this wind speed, but the wind speed is wrong. So there comes the problem. In the next, we detect the stop and the curtailment status. Those status or two status is detected based on the concentration of the data point. We make a histogram of the data point, and we see the zone that we have many data points concentrate with the same level of the output power. This means this zone is classified as stop or curtailment. And for the next two status is the partial curtailment and partial stop. Those are the point at the beginning or in the end of a stop or a curtailment. As you know that the SCADA data is normally is arranged by 10 minutes, but during this 10 minutes, there's a lot of things can happen. Control signal which demand the wind turbine pass from the normal operation into the curtailment or into the stop mode. So those point in the middle of the two status that we call the passion. In those, this point has a particularity because, for example, for the first 3 or 4 minutes in the beginning, it's operated normally, But in the 6-7 minutes later of this 10 minutes, the wind turbine goes to in another mode of operation. So this point will be detected and classified because when you calculate the output power of this data point, it will have a value in the middle. It's not really stop, but it's not really in the normal functional also. So it will be in the middle of the two status. So it will be classified and treated separately. And after this 7 operating status has been detected and classified, the data point which rests will be defined as a normal operation.
Okay. And so we are totally agreed that this software give you the 8 operating status automatically. So it's so it gave to the users a time saving and a fast detection. So being an operator is not required to understand how a wind farm works, and it's very simple because you doesn't need again the status code to obtain this classification. You only need the SCADA data.
Yeah, in fact, our detection algorithm work with very minimum of the variable. In the first case, we need only the wind speed and the output power for the detection. And if you have the pitch, we will include it into our algorithm. So maybe 2 variable or 3 variable minimum is necessary.
Yeah, okay. Okay. The next point is about the real power curve recalculation by WPA. Very interesting, these points.
Yeah, in fact, when we have detected the normal data point, the calculation of the real power curve is become much more easier because we will use only those normal points for the recalculation. And the calculation is done with respect to the IEC standard. And during the recalculation, we propose 2 corrections. The first one is the nascent transfer function correction. This nascent transfer function correction take into account the behavior of the wind speed after the blade. So it's take into account the rotation, the effect of the rotation of the blade. Normally, this effect has been taken into account by the manufacturer. They propose also a nascent transfer function correction, but with our return from our client, sometimes this transfer function is not very good, or sometimes they do not include this correction in the data. So we provide a possibility for the user to include this correction freely by their own. So I think it's a real advantage. And the second correction is very traditional. It's a density correction based on the temperature, air pressure, and the humidity of the air. It's the traditional correction based on the IEC standard.
Okay, so we are agreed to say that the software gives you a briefly check of the wind turbines working, and you can check the correct performance of wind turbines and compare to the theoretical one provided by the manufacturer. And a point very important as well, you can use this recalculated power curve to use in another wind project for repowering, for example, or for wind assessment project. For instance, Meteodyn WPA. The fourth point is you can perform wind farm analysis with loss identification.
Yeah, the losses is estimated by applying the measurement wind speed to the real power curve detected in the previous step. So the idea here is very simple. We detect the normal point, we view a real power curve based on those points, and we calculate the losses of the other six other operating status without the measurement error. The measurement error is excluded permanently. So we recalculate the losses of low data point based on the real power curve. And here we provide, besides the total losses, we try to break the losses into monthly losses and the and the losses classified by category. So you can understand in when your wind turbine have high losses, which month in the year, which month during the whole period of operation, and you can understand which category of operating status cause the much of the losses. Here in the figure, you can see that in this wind turbine, the losses come from stop is responsive for nearly 90% of the losses.
Yeah, so these losses in notification give us three main indications. Which of the wind turbines are underperforming, of course, the cause of this underperformance, and when it occurred. So three very important information we need to know when we have some losses, so some production losses. The last feature, and not the less important, because this is the key indicators that we have integrated in WPA to monitor wind farms and wind turbines.
Yeah, so those indicator will help you to have a general view on the operating status of each turbine in the wind farm. And besides the popular indicator based on the average values such as the daily production, the capacity factor, the average wind speed, etc., we provide some special indicators such as the TBA, PBA, which is the time-based availability and the production availability of your wind turbine. The MTBF, mean time to before failure, MTTF, mean time to failure, and MTTR, mean time to repair of your wind turbine. So, and not only the indicator for wind turbine, but we also calculate the indicator for the whole wind farm. And we are capable to compare between each wind turbine, and we are capable to compare between each wind farm in your project.
Maybe an explanation about MTBF, MTTF, and MTTR. Can you precise what does it mean?
Yeah. The MTBF is the mean time before failure, and MTTF is the mean time to failure. So it's the duration of the time between two failures of a wind turbine. And the MTTR is the mean time to repair, is the average time needed to repair your wind turbine to bring it from the failure state to the operation state. Those three indicators is very important in the operation and maintenance of your wind turbine wind farm, and it justifies the quality of your equipment and the quality of the service from the operation and maintenance teams.
Yeah, and we are agreed that those indicators are automatically calculated by the software, right? Yeah. So that's relevant indicators to help you to monitor your wind farms. So it can detect several types of anomalies by comparing wind turbines and wind farms between each other, and it's efficient and easy to perform assessment of wind farms and wind turbines thanks to this clear display. Yeah. So maybe now we can have a look to the software finally, and look how all of these tools are working together. So I will give you the end right now. Let me 2 seconds. Okay, so now you can use the software.
Okay. In fact, we have just presented to you the main feature of the WPA software, and based on those main feature, we are building several analyses which have the user to easily visualize and understand what happened to their wind farm. And for example, we are looking at this wind turbine, and here we have several analyses. I will begin with the power curve analysis. So this analysis will give you the general view of your power curve with every classification that I mentioned before.
Mm-hmm.
And here you can see the green power curve, which is detected in the black color, and the manufacturer power curve in blue. You can see that the theoretic and the real power curve is not the same. There's some region when the real power curve is better, and there's some zone where the manufacturer power curve is perform better. But in any case, the black one is the real power curve of your wind turbine. And this is the general vision of the whole data, but our software is capable to give you some more detail. For example, you can have a look in the time mode, the monthly. We have the monthly, the day, night, and the season. For example, in monthly, we will break this whole data set into months.
For every month.
Yeah, we will have a power curve for each month of the years. Here we are working on the 5-year data set from 2012 to 2016.
Yeah, so it's a big one. It's a big data set. Yeah.
It contains about 200,000 of data points for each wind turbine. So here we have a vision on each month of this wind turbine, the power curve for each month, and for each month you calculate also the losses by category, the measurement value, etc. So everything is detailed here month by month. We can have here a filter to help you to select exactly the periods of data that you want to process in the analysis. This filter is a general filter which could be applied into every analysis. For example, I switch into the time series analysis. We still have this filter here. The same filter helps you to select the exact period of data that you want. In this time series analysis, you can have a look at your data in the time series view. So here is we are from the January 1st in 2012, and the end here is 31 December 2016. And we can here select the data source if you want. Here we provide every source that you put in the input of the program. So you can freely select the data source you want, and you can have the vision of those data in time series. The time profile analysis is another interesting function which give you something more statically. It means that, for example, here we have a time profile of the wind speed in a day for 24 hours of a day. So for each hour is calculated from the average value during the 5 years. And here you can see that for this wind turbine, the wind speed is lower in the morning, about 8 from 7 o'clock to 9 o'clock. We have a slow in the wind speed here, and in the night it's very wind speed become higher. So this is very interesting if you want to use this time profiles for the estimation or for the modeling of your wind turbine. And the speed analysis.
Meantime,
Yes.
we can add something very important. For each graph, we can display the table with all the values, and we can export it to a CSV file or a TXT file. Yeah.
Yeah, of course. In the universe, everything can pass into the platform between our software module, but we provide also the possibility for the user to export the data to the CSV, so they can manipulate it outside the software. We can have a print screen here, which have the user to copy the chart into the clipboard. So I think it's very easy for the report to, if you want the user want to make a report, they can have print screen, they can export this view and copy paste it into the report. Yeah, the next function is the wind speed analysis. So this module will help the user to understand more about the wind speed of which is measured by the nacelle of this wind turbine. So we have here the distribution of the wind speed, the wind rows, and the power rows of your wind turbine. I think the most powerful function here in our software is the cross data analysis. So this function have the user to create the relationship between three variables by their choice. For example, here we have the traditional view between the relation between the wind speed in the x-axis and the active output power in the y-axis. This one is colored by the direction. User can change the variable. They can choose between the variable that in the input. For example, I choose here the pitch, and we can see the relation between the wind speed and the pitch. So this relationship is a little atypical. So here we see the pitch. Normally, when we are in the normal operation, the pitch when the wind speed is low is nearly 0 degree, maybe up to 2 or 3 degree only. The idea is to extract the whole kinetic from the wind in maximum the power production. But when you see that when the wind becomes stronger at 11 or 12 met per second, then the pitch will increase. The idea is to reduce the absorption of the kinetic from the wind in order to maintain the output power of the wind turbine at the nominal power. Because if the wind, the pitch stay at the zero, the wind turbine will rotate very fast and maybe damage the mechanical system. So here is they reduce the absorption in order to maintain the wind output power at the nominal value. Here, when you have a look at this relationship, we can understand a little bit about the control strategy of the manufacturer, which I think is very interesting. Everyone know that to stop the wind turbine, they will set the pitch to the 90 degree. Here is very clear that we have 90 degree is here, and it means that the wind turbine is stopped at its for those data points. But we see another line here, which are interesting, is the 45 degrees, is in the middle. So it's here we are having a detailed look on the control strategy of the manufacturer. Is instead of letting the wind turbine the pitch at 90 degree, they put the pitch at the 45 degree. At this angle, the wind turbine, the blade is mostly do not absorb the kinetic power of the wind turbine, so the production is nearly with a stop. But however, from this position, is much more easier to return to zero. So the blade will rotate less. This cloud point is the transition between the 45 and the zero. This means that the wind turbine switch between the stop and the operation. So by giving a quasi stop here at the 45, the manufacturer can optimize the use of the rotation of the pitch. So I by the with the help of this control strategy, the manufacturer can optimize the use of the motor of the pitch. There's less rotation. And so this I will come back with the conclusion is the cross data analysis is a very powerful function which have you discover is the functional the operation of your wind turbine. We admit that there's a lot of combination between the input variables, so we are not fully because for example, if you have 10 input variable, the combination will have 700 possibility of the combination. So we are still working on this combination to understand better of the operation of your wind turbine.
Yes, thank you, Mintang, for his presentation. Very complete. So now we will see what the software can do with a specific case. So for that, we have prepared a specific case in France called La Haute-Borne, operated by ENGIE and developed by Maya Eolis. So it's a small wind farm in France, in north of France, but there is some interesting facts to notice. So Mintang, I let you make the presentation.
Yeah.
Do you need the PowerPoint here?
Yeah. In fact, for this wind farm, I will show you some interesting point that we find out during the analysis of its operation. Firstly, I would like to make clear with you that the production of the wind turbine is different from the performance. And you can see here we have 4 wind turbines in this wind farm, and the performance of those 4 is very close one to each other. We calculate, and they have a difference of 4%. But here you can see that we have a very different in the production. So for example, we have the lowest performance. The wind turbine with the lowest performance is the first one, but they has the highest production, and the highest performance is the second one, but in reality they have the lowest production. So the production of the wind turbine is depend on a lot of other variables, such as the availability of this wind turbine, the wind speed, and etc. So what we like to aware you that good production could hide the several performance issues of a wind turbine. If you see a wind turbine with good production, but it's not sure that everything is okay. This can maybe when we calculate the performance is not as good at the production, and it's had to remember that the performance reduction is the first symptom of the component failures. So the analysis on the performance of the wind turbine will show you the real problem of your wind turbine, and therefore help you to avoid the component failures when it happens. And in the next slide, um, ah, here we have detect also the fourth wind turbine, which has a huge losses here. And based on our, with the help of our time series analysis, we understand immediately what happened to this wind turbine. There's a stop from the April 2012 to December of this year. So it's maybe 8 months of stops. So it's increased 30% of losses. The next one I would like to show you is the degradation of the power curve over the times. Here, as I said earlier, we have 5 years of data, and we process to the calculation of the annual power curve of this wind turbine. For each year, we select the data and we calculate a power curve for this year, and we observe that this power curve is degraded years after years, and the performance is reduced from 3,500 to 3,100, 200 after 5 years. There's a huge degradation over the years, which has been detected by our software. We don't know the cause, but it could help the operator and the operation and maintenance team to raise aware and to have a look closer on the detail of this degradation. The next one, based on the same type of analysis, is the analysis of the seasonal and the day-night effect of the wind turbine. So with the same approach, we separate this the data point of this wind turbine into 4 seasons, and we have a conclusion that in winter the blue power curve, this wind turbine has the highest performance. In summer, the red one is the lowest performance, and in the spring and in autumn, we have the same characteristic, which is in the middle. So the explanation could be based on the temperature. In the winter, it's much colder in France. We are here in France, so it's colder in winter than in summer. So the density of the air is much more higher than in summer. Therefore, the kinetic of the wind with the same speed is higher, which provides much more energy than in summer. The same analysis, but with the day-night effect, we separate our data point into day and night, and we can see that in the night, the blue power curve has a better performance than in the days, the yellow one. But the difference is not very significant. It's one of our surprise, because in the beginning we thought that in the day and in the night the difference is much more higher than that. But the data shows that there's differences between day and night, but the difference is not as high as expected. Yeah. So are some interesting point that we would like to share with you for this wind farm.
Yeah, and thank you, Mintang. Very interesting. This is one of the analysis we can do with WPA. So now it's over for the Meteodyn WPA presentation. Now, if you have any questions, be free to ask us. For now, we don't have any question, but in order to wait a bit, I will ask a question for you, Mintang. Maybe it will be interesting for the attendees. What kind of SCADA data we can import into the software?
For the data SCADA variable, we organize as three type of variable. The mandatory one is the variable that you must have in order to run the program. It's very little. We need only the wind speed and the output power of the wind turbine in order to run the program. Then come the secondary type of variable. Those are the variables that is better to have. Those are the pitch, and the wind direction. Other than two type of data of a variable, user are free to import other variable to do the analysis on the cross data valid analysis. So for your answer, we can import as much as variable as the user want, but there's I think it's very the program is designed in a very open ways. It can work with a lot of wind turbine from different manufacturer. There's no limitation.
Okay, and someone is asking if we can import automatically the SCADA data into the software.
Yes, currently the data can be imported automatically based on a mechanism that you precise the location of the folder of the data, and then we go into this folder to look for the data automatically. In the near future, in the middle of the years, we will develop a real-time connection to the data, to the SCADA system. So at this moment, the program is connected 24 hours to the SCADA system, and the data will come in real time.
Yeah, the software is very beginning of its history, I mean. And of course, as for the other software like Meteodyn WPA, we'll develop new features and new improvement thanks to your feedback, thanks to the user's feedback. So of course, if you have some feedbacks to make, don't hesitate. So another question maybe. What other file types can be read besides CSV or TXT files?
In fact, currently the program can read the data from CSV files, and as I said, in the future we are developing the connection directly to the SQL database. So we are not trying to import another file type. We will stay at the CSV, which is very common data format, and then we develop the real-time connection to the SCADA system.
But what we can, I mean, thanks to the CSV or TXT format, we can import any kind of files. I mean, as you can see, there is a wizard we have developed, so you can customize your file configuration to import any kind of CSV file. So no worries about the importation. It works very well. So so we have another question. Okay, is the SQL link operational now?
Not yet, but it's going to be operating in the next release. I think the 1.7.
Yeah.
Here is the 1.6. It's maybe released at the middle of the year in the month of June or July. Thank you.
Okay. Okay. So we do not have any more questions. So thank you, everyone, to attend this webinar. It was a pleasure. Last word, Mintong, before we leave.
Yeah, thank you very much for the participation of our webinar, and we'd like to see you in the next event.
Yeah, the next event will be about the Meteodyn WPA software, so the Win data analysis software. So for now, the date is not scheduled, but of course you will be warned when it will be scheduled. So stay tuned. You will receive the information by mail. Anyway, so thank you for your attention. If you have any questions, do not hesitate to send me an email. So Anthony with H and Y .dijon at meteodyn.com, and you can get a lot of information in our website. So www.meteodyn.com.